So, part B, express the number of fans cheering for school B as a percent of the fans cheering for school A. So we need that information from the last one. So we said A was 370 and school B had 555. And so this time it says as a percent of the number of fans cheering for school A. So of school A, part, percent, and whole. Again, we're looking for the percent, so that's what we do not know. And of school A. So of school A means of the whole. So our whole is going to be 370. And our part is going to be 555. And so therefore we know we're going to get a percent that is going to be greater than 100 because our part is greater than our whole. So part equals percent times the whole. Part is 555. Percent is unknown. And the whole is 370. So we're going to divide both sides by 370. Just move this up a little bit. And so 555 divided by 370. 555 divided by 370, 1.5. 1.5 is equal to x. We need to move that decimal 2 places to the right because it's a percent. So 1, 2 gives me 150%. Okay. What percent more fans were there for school B than for school A? So school B had 50% more. I'm looking at this 150. So school A at 100% would have 100%, and then school B had 150. So we actually needed to use part B for this question, not part A. There were 50% more fans cheering for school B than school A. Okay. Number 4. Rectangle A has a width of 8 centimeters and a length of 16 centimeters. Rectangle B has the same area as the first, but its width is 62.5% of the width of the first rectangle. Express the length of rectangle B as a percent of the length of rectangle A. What percent more or less is the length of rectangle B than rectangle A? Okay, so the very first thing that I want to do is I want to get an idea of what this is asking me. So first of all, I'm going to draw that rectangle A. Okay, so it said width was 8 centimeters and the length was 16 centimeters. And so this is rectangle A. Rectangle B has the same area, so that means when I do length times width, area equals length times width, I'm going to get the same number, but its width, so the 8 is 62.5% of, so we're multiplying it times the width of the first rectangle. So 62.5% of, so let's move that decimal 2 places to the left, 1, 2, so we're going to use 8, let me go and do that. So 62.5%, so the percent of means to multiply times the width, so was 8. And so when I do that, 0.625, 625 times 8, I get 5. So the width of angle or rectangle is going to be less. So this is going to be 5 centimeters. And so this is how I got the 5 centimeters. Okay, it's got to have the same area though. And so it says express the length of rectangle B as a percent of rectangle A. So we know that this has got to be longer because this is smaller. So 8 times 16, we need to find our area here. So area is equal to the length times the width. So 8 times 16, 8 times 16 equals 128. So the area is equal to the length times the width, and that gave me 128. So my area on rectangle A is 128, and so my area on rectangle B has to be 128 as well. So I need to find what I'm looking for is I'm looking for what is this length going to be. So area is equal to the length times the width. Well, we know the area, they're supposed to be the same. This is B. So the area here has to be 128. And we're looking for the length. So that's something that we do not know. We don't know the length. But we do know the width. The width is 5. And we figured that out earlier. And I like to do my L more cursive so it doesn't look like a 1. And I get confused. So now I'm just dividing both sides. I'm solving that equation for the variable. Divide both sides by 5. So 128 divided by 5. 128 divided by 5 gives me 25.6. So 25.6 is equal to the length. So this length is going to be 100 and, whoops, not 100, 25.6 centimeters. 25.6 centimeters. So I needed to know that length. But I still haven't answered my question. It says to express the length of the rectangle B, so we want this, as a percent of rectangle A. Okay. So now I'm ready for my part, percent, and whole. So it said of A, so a percent, we don't know, of A, so the length of A was 16, so that's our whole, and our part, therefore, is going to be 25.6. Because our part is greater than our whole, we know we should be getting a percent that is greater than 100, because it was bigger. Part is equal to percent times whole. So our part is going to be 25.6 is equal to our percent we don't know, and then our whole was 16. So we're going to solve for that variable, divide each side by 16. So 25.6 divided by 16. 25.6 divided by 16 equals 1.6. 1.6 is equal to x. Remember we were looking for, I don't know why that happened. Remember we're looking for a percent, so we need to move that decimal 2 places to the right. So 160% is our answer there. 5. A plant in Michaela's garden was 40 inches tall one day and 4 feet tall 1 week later. By what percent did the plant's height increase over 1 week? First of all, I see 40 inches and 40 feet, or 4 feet. So I need to take those 4 feet and make them into inches. So I'm going to do 4 times 12 feet in a foot. So 4 times 12 gives me 48. And so we're doing 48 inches is what we're actually going to use there. And I see that word increase, meaning I need to figure out the part, which I need to do 48 minus the 40 to see what the increase, the change was. And so our change there is 8 inches. So our change is our part, which was 8%, and then whole. And we're looking for the percent, so our whole is going to be 40. Our original. So P is equal to percent times the whole. Part is equal to percent times whole. 8 is equal to x times 40. Divide both sides by 40. And so when I do 8 divided by 40, 8 divided by 40, I get 0.2. 0.2 equals x. X was a percent. Always go back and look and see what you were looking for. Move the decimal 2 places to the right. Gives me 20% increase. That plant's height and grew 20%. And finally 6. Lauren must obtain a minimum number of signatures on a petition before it can be submitted. She was able to obtain 672 signatures, which is 40% more than she needs. How many signatures does she need? So 40% more than, so she had 100%, she got 40% more, so she has a total of 140%. So part, percent, and whole. So we want to know our percent, right? No, sorry. We want to know the whole. We want to know how many did she need. She needed this amount. She has 140% of what she needed. And so what she has 672. So our part is going to be the 672. Part is equal to the percent times the whole. So the part is 672. Our percent is going to be 1.4. And our whole we do not know. Divide both sides by 1.4. 672 divided by 1.4 equals 480. Okay, and that makes sense. She needs 480 signatures. She got more than she needed. So 672 is how many she had, which was 40% more than our 480 signatures. Okay, identify the lesson summary, identify the type of percent problem that is being asked as a comparison of quantities or a part of a whole. So we're identifying our part, percent, and whole. Identify what numbers represent those things. And remember we said our quantity is the same thing as saying our part. And then a strategy to solving percents using mental math to rewrite the percent as 1%, 5%, or 10% so that they could be solved mentally. Go ahead and do your problem set. Do numbers 1, 2, and 3. And you should be doing it on a loose leaf sheet of paper and not trying to squeeze it on here.